Hey guys, my name is Reno and today I'm going to be teaching about reflections. Alright, so what are reflections? So, a reflection is a transformation that uses a line like a mirror to reflect a figure. The mirror line is called the line of refraction. A reflection in line M maps every point P in the plane to a point P apostrophe or a second point, a reflected point, for example. So that for each point, one of the following properties is true. If P is not on M, as you can see here, point P is not on M, then M is perpendicular the bisector of P, and P is a perpendicular bisector. Or if P is on M, then P is equal to the P apostrophe. Alright, so reflecting horizontal and vertical lines. Graph triangle ABC with vertices A 1, 3, B 5, 2, and C 2, 1, and its image after the reflection described. In the line N, X equals 3, and in the line M, Y equals 1. Pause the video, give it a shot, and then come back for the right answer. Alright, so now that you're back, the answer A would be A 5, 3, B 1, 2, and C 4, 1. As you can see here, the blue figure is the original figure, and the red being the new figure. Point A was 1, 3, and then line N being the line of reflection. How many units to the line? 2, so it's going to be another 2 points or units, so it's going to be 4 units in total, which gives us 5, 3, and then B was all the way over here. B was 5, 2, so subtract 4, which gives us 1, 2, and then C 4, 1 is just 2, so add 2, so C 4, 1. And then the line M Y equals 1, here would be A would be A 1, -1. So you can see here we're bringing it down -4, so 1, 3 minus 4, which gives us 1, -1. B 5 is to 0, 2 minus 2 gives us 0. And C is on line M, so as we learned earlier, C is equal to the new figure C. Reflecting in the line Y is equal to X. Graph line segment FG with endpoint F, -1, 2, and G, 1, 2, and its reflection in the line Y is equal to X. Pause the video, give it a shot, and then come back for the right answer. Alright, so now that you're back, the answer, line FF, as you can see here, is perpendicular to line Y is equal to X, as you can see here. It has a perpendicular symbol here. So line FF has a slope of -1. So F from this point has to move 0.5 units to the right, and then 0.5 units down to get to the line, and then G has to move 0.5 units to the right, and then 0.5 units down to get to Y is equal to X. And then both the points has to move the same amount of distance to create the reflected line segment. Alright, so coordinate rules for reflections. If A, B is reflected in the x-axis, then its image is the point A, -B. If A, B is reflected in the y-axis, then its point is -A, B. If A, B is reflected in the line Y equals X, then its point is B, A. If A, B is reflected in the line Y is equal to -X, then its point is -B, -A. Alright, so the reflection postulate. So reflection is a rigid motion. The composition theorem also applies for any type of transformations, including reflections and translations. A glide reflection. So a glide reflection is a transformation involving a translation followed by a reflection, in which every point P is mapped to a point P and then a quotation mark, just for representation. So how this would look like. So step 1, the translation occurs. So P goes to the second point, the translated image, and then next after the translation, the image is then reflected again to create the two transformations. Alright, so performing a glide reflection. Graph triangle ABC with vertices A 3, 2, B 6, 3, C 7, 1, and then its image after the glide reflection. translation. The translation is going to be x comma y, and then x minus 12 comma y, and then a reflection across the x-axis. Pause the video, give it a shot, come back for the right answer. Okay, so now that you're back, so first off, we're going to need to translate. We're going to translate 12 units to the left, or negative 12 units, and that's going to give us our translated image here: A, negative 9 comma 2, B, negative 6 comma 3, and C, negative 5 comma 1, and then we're just going to reflect it over the x-axis, which just makes all the y coordinates negative. Alright, so identifying lines of symmetry. A figure that has a line of symmetry when the figure can be mapped onto itself by reflection in the lines. So as you can see here, a line of symmetry is basically when you cut an image in half. It should be the same thing, just in opposite direction, or it should be the same thing when you put it on top of it. So yeah, it should look the same when you divide it in half in any direction, and a figure can have more than one line of symmetry. Alright, so how many lines of symmetry does each hexagon have? Pause the video, give it a shot, come back for the right answer. Alright, so number A. Number A has 2 lines of symmetry. As you can see here, we can divide it up and down, gives us 2 symmetrical figures, and then left to right gives us 2 symmetrical figures. And then for this one, the middle one, this has 6 different lines of symmetry: 1, 2, 3, 4, 5, and 6. If you divide it in all 6 of these directions, the figure will look the same at the end. And then for this one, this only has 1 line of symmetry going left to right, and that's the only cut that will give us a symmetrical figure. Alright, so if you found this video educational, leave a like, subscribe, and then come back for more educational videos like this.